After taking that little detour on ACI approximate moments, let's get back to our slab design. And so the procedure is first we're going to choose the thickness. Remember we talked about L over 24 for exterior spans and L over 28 for interior spans. You're going to get the moment from, in this case, we're going to use these ACI approximate moments. And then once you do that, you get Mn equals Mu over phi. That's the Mn required. And just like we did in the beams, we're going to do Rn is Mn over Bd squared, where we're doing a 1 foot width of the slab. And then you're going to calculate rho from that long equation we did for the beam. And As is rho Bd. And have to check As min. And there's a slightly different formula for As min for slabs. We'll talk about that in a little bit. And then the last step is to pick the steel. And remember, this is for a 1 foot wide section of the slab. So let's say you get As equals 0.3 square inches after you do all the calculations. What that really means is As equals 0.3 square inches every foot. You don't have to have it just needs to average to that. You don't have to have 0.3 square inches every foot. In fact, we don't have a bar that size. So to pick the steel, you don't have to put 1 bar in every foot. You just need to make it average out, except there are rules. You cannot put them more than 3 slab thicknesses apart, okay, or more than 18 inches apart. Also, if you have them closer than 1.5 slab thicknesses, that's a lot of bars. That might be too many. And so the best way to do that is to use a table in a book, or if you're in my class, this is not hard to do. You can just make an Excel sheet to do this. So I made my own Excel sheet. And so, for example, let's say we are looking for 0.3 square inches every foot. So if you want a number 3 bar, you would have to put it, here's the As greater than 0.3. You'd have to put a number 3 bar every 4 inches. A number 4 bar, oh, perfect. A number 4 bar every 8 inches. A number 5 bar every 12 inches. And a number 6 bar every 17 inches. And you can't put them more than 18 inches apart anyway. And so number 7 every 18. You just pick which one you like the best for you. And also the spacing has to be less than 3 slab thicknesses. That will also govern the spacing. Okay, you also need to check shear. It won't control. We actually haven't talked about shear yet. We'll talk about shear in beams first, then shear in slabs. Where shear does control in slabs is punching shear, which is not applicable to one-way slabs. And then you need to put temperature and shrinkage steel in the perpendicular direction. So if Fy is 60 ksi, you have to have 0.18%. These are really small. If you have Fy is 50 ksi, 0.20%. And if you have something other than those two, you ratio relative to this 0.18% for Fy60. The weird thing is we're used to doing As is rho Bd. I know this is confusing. For slabs, you use the actual total depth H, not D. B, remember, is 12 inches, and H is the depth of the slab, the whole depth, not D. And you use this perpendicular to the main steel. This is the other weird thing. These are also the minimum amounts of main steel, okay? So this amount is also the minimum in the direction of the bending of the slab. Let's compare what we just talked about, the beam design. In the beam, remember, we would pick a row and then get BD squared. We would pick a row, get the RN, and then Rn over Mn is BD squared, and we get the B. For the slab, B is just 12 inches. Remember, for the beam, after we pick the width, we get the D from the required BD squared. The thickness of the slab is just going to be from that table, L over 24, L over 28. In a beam, D is about H minus 2.5. For a slab, there's no stirrup, and you get to use less cover, and you use smaller bars. So D for a slab is about H minus 1 inch. And usually the calculated row when you finish your design for a beam is comfortably within the max and min. In a slab, because the moments are so small, often the calculated row is below the minimum. And we do not use this row min equation from the chart, use this temperature steel amount. And typically, you're going to use grade 60, so it's going to be 0.0018. The width is 12 inches times H, the thickness of your slab. That's how much square inch of steel per foot of width of slab that you have to have minimum. Okay, I'll stop here, and the next video we'll go over an example from the Nielsen Dolan textbook that we're using.